Hey guys, this is an examples video where we're going to be looking at continuous functions, composition, and limits. These are the three examples I'm going to go through in this video. You can always fast forward to the example that you want to see, or if you want, you can pause here, quiz yourself, and then hit play when you're ready. So starting with A here, so this first one I've got the limit as x approaches 0 of the cosine of x plus cosine of pi over 2 plus x. So the whole thing here is, this is a composition, right? So this function is composed in this one, which is composed in this one, which is like, these are all composition of functions, but these are all continuous at x equals 0. So because of that, we can actually just kind of evaluate by starting in the inside and working our way out. So what I mean is I can actually just plug like 0 right into this because I know that these are all continuous. So it's going to be nice and easy peasy. So as we work through this, so this 0 is going to have no bearing. This is going to be just the cosine of pi over 2. What is the cosine of pi over 2? It is 0. And then what is the cosine of 0? It is 1. So that's like all you have to do with examples like this. And it's all about when you know that something is continuous. That's really, really key. Okay, so here for B, so I've got the limit as x approaches pi of the cosine of the sine of the tangent of x. And so you do have to be careful with tangent because tangent's not continuous everywhere, but it is continuous at pi. So I can leverage the fact that this is a composition of continuous functions, at least at pi. And so what that means then is I can go ahead and just plug in pi. So the tangent of pi is equal to 0. So then I have to take the sine of 0. The sine of 0 is equal to 0. And then the cosine of 0 is equal to 1. Boom, done. Okay, and so for this last one, so this is one more where we've got to just examine this. So I've got the inverse sine e to the cosine of pi over 2 plus x, and I need to take the limit as x approaches 0. So once again, these are all continuous functions, at least at 0, right? So as long as you're continuous at 0, you're kind of good to go here. So this is going to be just plugging in then that 0, and now we're just going to work our way out. So this one's going to be e to the cosine of pi over 2, which is 0. So this will just be now e to the 0, and e to the 0 is 1. So now I just have to think about inverse sine. So what value on this domain, and by the way, the domain goes from negative pi over 2 to pi over 2, so what value would give me 1? This would just be pi over 2, so that would be our solution in this case. So when you have that something is not continuous on that point, then you have a lot more issues, and then that's where you have to go through all those algebraic tricks. But if you know that it's continuous, it makes it nice and easy. And so that actually concludes this very short video. So if you have any questions, feel free to drop them in the comments. I'm always reading. Thanks for watching.